So last year I started off by talking about New Year's resolutions, and oh, it's cool. We've got the screen here. And I was going to make some money, have an SSB QSO, be nice to the wife, be nice to the kids. Now, obviously, none of those things happened at all. So this year, just recycle last year's New Year's resolutions, so we don't need to talk about that. So what I want to talk about this year is Junkbox projects. So in recent years, I've stood here and I've given some quite detailed technical talks on various QRP Labs products and very heavy stuff. So this year I wanted to go right back to basics and some of the favorite things that I've built over the years. So forget about all your posh aircraft stuff or your kits from these silly kit companies like QRP Labs or people like that. And just we're going to talk about junk. And firstly, we need to talk about what is a Junkbox project. And you could define this various ways, but I've put the definition that I'm going to use up here, mostly from stuff that you would have lying around in your storeroom or whatever. This picture comes from my storeroom. It's a very small, only about 4 feet high cubby hole where I put all my junk. It shouldn't cost more than $10 if we do need to buy something. It's quite likely when you make a project that you'll not have everything that you need on hand and you might need to buy something. No microcontroller programming, and possibly you could put some time constraint, like it should be quite quick to make. Junkbox, where you get your Junkbox. And I've been collecting, I'm going to put some stories in this talk as well because it's not too technical, just to entertain us. Looking for trash, and this is what I used to do. We had a rubbish dump, what we call a rubbish dump in England. I don't know what you call it in the US, in the village where I lived. And I used to go down there and rummage through all the big containers and look for old televisions and old radios, and you could find quite some treasures in there sometimes. And it used to be a regular sort of summer evening activity to cycle down there and climb over the 6-foot fence at the back, and when it was all closed in the evening. It all went very well until one evening, the government council guy who ran the thing had actually stayed later than 5 p.m. Obviously unheard of for a government worker. And he was still there, hiding in his shed or whatever it was where he tried to extract some of the valuable stuff and sell it. Now, this guy caught me in there, and I'd never heard, to this day, before then or after then, so many swear words come out of one person's mouth. I was just a child, If this was America, you'd be able to sue him for psychological damage. It's still affecting me today. I wouldn't be able to, we're all adults here, I would not be able to repeat to you what he told me. It was unbelievable. And then he called the police. So the police drove me home and delivered me back to my parents for a teenage delinquent here. And, they're rolling their eyes, look at the inside of their brain like that. And yeah, we'll tell him off, don't worry, we'll tell him off. And obviously the following evening, I was back on my bicycle downtown. But I used to get a stick and throw it at his shed and see if he came out so I could know if he was in there or not. My next tip is be very nice to your mother-in-law. And for many reasons, obviously, not for the reason that she's going to give you her old junk when she throws it out. So I had quite a few nice things donated through that route, which is also useful. And then under the tables at the flea market, this was a tip from George Dobbs, Reverend George G3RJV. I remember he used to talk here, and I think one of the years he was talking here, he said that all the treasures in Hamvention and Hamfest in the flea market are underneath the tables. They have these dollar buckets or sometimes even free buckets, and you can pick up a lot of useful stuff in there. So remember that when you walk around the flea market in the next couple of days. There's also, in my case, a lot of failed projects which never worked, or projects I never finished and forgot about. You only hear about the successful projects which do work, but they're outnumbered about 10 to 1 by the ones that don't. And some of you might be the same. So there's a lot of unfinished kits and projects, and I often just attack those and salvage parts from those. The other thing is you can get these very nice assortments that I've shown a picture of here for $50, $40, $30 from Amazon, you can get one of these component sets, which has got thousands of components in it, which it gives you an instant junk box to scavenge from. There are always some things which you need, which you will not find in your junk box. The three things that I could think of were crystals. Often we want to make a transmitter and we want to make it on QRP lamps. Sorry, not QRP lamps, but I said we're going to forget about them. QRP frequencies. And for that, you need special crystals. And one of the best places I know is this KC9ON website. He has a very large selection of crystals, many of which are on the QRP calling frequencies. NP0 capacitors are quite important with the low drift coefficient. Not so much for VFOs, which is why everyone thinks that they need them, but they're also very low loss for filters. So I always recommend NP0 capacitors for low pass filters, band pass filters. And DigiKey have these very easily. And DigiKey have a $4.99 minimum shipment for small packages. So it's quite economic, even if you want a few small parts. And then toroids I get from kitsandparts.com. Again, you're unlikely to find toroids in any commercial junk which you salvage, or you'll find some toroids in a switch mode power supply, for example, but it probably won't be useful for RF. So these three are my favorite places to shop for things which I need, which are not in the junk box. Junk box construction, I very often use unetched PCB material and just solder everything to that as a ground plane. It works very well. If you don't have that, you can just cut some tin, as I have done here, from an old food tin can. And the tin plating is actually very easy to solder to. And because it's got a low heat transfer coefficient, it doesn't dissipate the heat as easily as a copper-clad PCB would. So it's very easy to solder to, very nice material to work with. So I have here my top 10 junk box projects, my favorite projects, just maybe of some interest. And this is the first thing which I built when I was about 6 years old, maybe 7 years old. It was a Christmas present, and it was a kit. Sorry, I wasn't going to talk about kits, was I? I was going to talk about junk box. Anyway, we'll pretend it's not a kit, but it actually was. And it was a simple crystal receiver, which I was amazed to attach, 10 meters of wire to it and to be able to hear signals. But some years later, I built the project I actually talk about here, which is just to add an amplifier to it, and it gets a much more sensitive receiver. I know there will be a lot of people in this room who will say that all of this is completely wrong, and that's not how you bias transistors. And I know. I was only about 10 or 9 when I built this, and it did work. I didn't know anything about biasing transistors, so I just connected things together and see if they work. So this was a really nice project, and I had a piece of wire down the garden, and I used to be able to listen to Moscow World Service and the BBC World Service and all these shortwave stations. Next up, I have a dummy load power meter. This is just a very easy way to make a dummy load. If you want to do any work with transmitters, you're generally going to need to have a dummy load, and you're going to want to know your power output. And so a very simple way to do this is just to get 1K resistors, 20 1/4 watt resistors will be plenty for a 5-watt dummy load. If you don't pack them all too tightly, and they can evaporate some heat away. And just solder them all in parallel like that onto the old piece of BNC cable connector, and you've got an instant dummy load. To calculate the power output, you look at the VPP on an oscilloscope, the peak-to-peak voltage, and square it and divide it by 400 is the formula for that. So a 5-watt signal is about 45 volts peak-to-peak. You can also, if you don't have an oscilloscope, you can make a very simple RF rectifier with just a diode and a capacitor, and you can measure the voltage across that with a digital multimeter. And if you do some calibration, you can come up with a curve and read off the power from that. This curve came from the manual of one of the dummy load kits in the QRP Labs website. And whatever you do, it's not going to be exact, but it'll be an approximate indication of power, and that's very useful if you're making a transmitter. If you wanted a nicer power meter, you could just salvage one of these old VU meters from an old cassette recorder or something. Probably there's some young people here who don't know what a cassette recorder is. Seriously, we had an employee in the QRP Labs office. He was about 25. And I had this old data cassette recorder that I bought in about 1985 from Tandy in the UK, which was a shop like Radio Shack. They sold a lot of computer stuff and radio stuff. And he saw it on the shelf one day, and his whole face was like one big question mark. He's like, "What's that?" So I'm trying to explain to him what a cassette is. My kids, you have to explain to them what a CD is. They have no idea even, it's just technology moves. So most of these power meters, you can make a very nice dummy load. You again have to do some calibration. The 100K variable resistor that I have in there lets you calibrate the full scale. I set this one up as a milliwatt up to 300 milliwatts meter, but you can easily do it for 5 watts as well. So that's a simple power meter to look at the outputs of the transmitters. Now, a more advanced project, still on the power meter theme, is one that I built 2002 or so, and this includes a SWR meter and an L-match tuner as well. And I used this for my first few 100 QSOs, even first 1,000 QSOs, when I just used to use a random long wire antenna outside in the garden. And it was very effective. I believe I have a picture of the insides here. And I actually had my first QSO using this ATU. My first ever ham QSO was in 2002. And another interesting story about this one, I was CQing for days. So I had my 80-meter transmitter that I'd built. The whole station was homebrew. I think I have a picture of it here. And the whole station was homebrew, spread out all over the desk. And I was CQing and CQing and CQing for days, and nobody was answering me. And I thought, is this how it's supposed to be with ham radio? It doesn't seem right. And I sent a message to the GQRP Club Yahoo groups forum. Can anybody hear me? Because I wasn't getting any answers. And some guy who lived just 10 miles away, he listened out for me, and that was my first ever QSO. So it's about 10 miles, the distance. It was a 559 report. At that point, I thought, something's not quite right here, because I should be doing better than this. QRP is hard, but it's not supposed to be this hard. And so I went through the entire station, looking at every connection, how I've done something wrong. And what I found was this forward-reverse switch here, I'd actually labeled it upside down. So I had my wire in the attic, and I had tuned it for worst possible match, least power output, and I was transmitting half of the power into the bridge. So it was not surprising. So I changed the labeling rather than change the wiring. And following that point, I was having QSOs very easily all around Western and Northern Europe, and so it was very satisfactory after that. Now on to number 6. This is a nice transmitter by a friend of mine in Greece, Kostas SV3ORA. By the way, you may not be able to see a lot of these schematics in the pictures, but I do have everything in the conference proceedings book, as well as references to Kostas's website if you want to read more. He has a very nice website, a lot of projects on there. I really recommend having a look at that. As you can see, it can be built for 30 meters or 30 meters. Obviously, you shouldn't write presentations in a rush in the middle of the night. I think that should be 20 meters or 30 meters, but you can make that for a number of bands depending on the components you use. And he used just an old CB transistor, 2SC2078, and he gets 5 or 10 watts out of that. So the picture shown there is a version that I built or started building. It's another unfinished project where I used just a wire, enameled copper wire bobbin as the base for the project and also to wind the coil on. And it has a 50 ohm output suitable for connecting to an antenna as well. So it's quite a nice sort of very, very simple project with less than 10 components that you could throw together quite quickly and works very easily. And number 5, this is another interesting project. QRSS was my first real niche that I got into in amateur radio, and which led to the QRP Labs kits, of course. It was the first talk which I gave here, I believe, or maybe the second, I'm not sure, which was all about QRSS, which is very low speed Morse and other very low bandwidth modes. Because they're such low speed, they have a very low bandwidth, and we use some DSP programs on the PC to do the demodulation. So this was 2004, 2005 when I made this project, and it was again all made out of Junkbox parts. So it's an ideal candidate for inclusion in this talk. I think the only non-Junkbox part I used was this crystal here. 10.14 megahertz was the frequency that in those days that was used and still is for QRSS experimenters. So a very simple Colpitts oscillator, and I had put it in this polystyrene box just to slow down the temperature variations that would, because QRSS is such a narrow bandwidth mode that even the crystal drifts very slightly during the temperature changes in the day. You can see that frequency drift. Then there was a simple amplifier, two-stage amplifier, which produced about 350 milliwatts power output. And I had this all constructed in a very haphazard way there. You can see I put some brass shim, which I made into this kind of heatsink on the main transistor. And then a simple 2-transistor pattern generator, which shifted the frequency up and down by about 4 or 5 hertz at about 20 seconds in each state, in the low state, in the high state. And so when it was demodulated on a DSP program like Argo or Spectrum Lab that we used to use, it produced a pattern like you see there in the blue picture. Now, this had reception reports from all over the world, and the interesting story of the company is this one. In 2006, it was June 2006, I made a trip to Australia, and I spent 3 weeks with VK60i and his wife, and VK60i, David, and I knew each other very well from email and from Skype. He was also interested in QRSS and was a big fan of that mode. But we never met each other. Obviously, he's on the other side of the planet to what I was on, so it wasn't something we would just bump into each other in the club or something. And so I went to stay with him for 3 weeks, and he came down to Perth in Western Australia, down to the airport to meet me, and it was about 1 o'clock in the morning, and I'd been traveling for 24 hours, much like when I come here. And I was absolutely exhausted, much like now. Everyone's telling me this morning how tired I look. And I met this guy who I'd never seen before in my life, and I was going to stay with him for 3 weeks. And we went out to his car, and we drove 45 minutes up into the hills outside Perth, and it's pitch black. I'd never seen the stars like that coming from London. And it was also, everything was so surreal. And we got to his house, and it was about 2 o'clock in the morning. His wife was asleep. We went straight upstairs to his shack, turned on his monitor, and what did we see on the screen but my beacon transmission from back home in my attic in London? And obviously, unattended operations are not quite allowed, but this thing was, I could monitor it at least from the other side of the world. So it was a really nice, welcoming present to come up there and straight away go into his shack and see my own beacon on the screen. Now, the question comes to VFOs. You may want to operate on other frequencies than the crystals that you've got. And this is one of my favorite VFOs. It's a very stable VFO, just made from, it's got 2 transistors rather than 1. And the key feature of this is that because it's got this very light coupling to the tank circuit, any temperature-induced changes in the characteristics of the transistors here have very little effect on the oscillation frequency. And I've always been very successful with this VFO. I've found it's very easy to get it working, and it's always been stable. the stability then depends just on the components that you use in the tank circuit. So, and you can usually play with those. So if you need to add capacitance or different types of capacitors like microcapacitors or ceramics, they'll have different characteristics. And you can sometimes work out how to cancel the drift of the coil part of the circuit. So it's one of my favorite VFOs. And this is an example of it that I built from an old television components. And this old television, by the way, this was something that was also salvaged from junk. And by the way, to this day, I wouldn't be able to walk past a discarded television that I saw in the street without picking it up and taking it home. I can't do it. Or anything else, microwave oven, radios, anything that I see discarded consumer stuff, I will almost pick that up and take it home. And in this case, it was back in 2008 when I first went to Turkey, where I now live, and was first introduced to my parents, future parents-in-law. We were not yet married. Actually, this was a trip I was going to ask for permission from her father if he minds if I marry his daughter. And of course, they took me around to show me all the old places, and they showed me the house in the village where she had grown up the first few years of her life. And it was an uninhabited cottage now. It was not in use, and it was completely empty. There was no furniture in there. But there was this television sitting there. So I was instantly, my eyes on this television, can I have that television? And it took me years to get hold of that television. And the reason for that was because my wife's cousins said to my wife's parents, this television is very old, it's antique, it's very valuable. You can't give that to Hans, they'll just take it apart. And so every year or every 6 months, whenever we went to Turkey and we visited, and the television was still there, and I was still asking, when can I have the television? No, we're going to sell that television. And next time this year, we're going to be millionaires. And eventually, there was a rich guy from Ankara who had a hobby growing rare orchids. And where we live is a very nice, warm area. Everything grows like crazy. You can't stop everything from growing. And he wanted to rent a place in the country where he could have a nice garden, and he could go there in the summer, and he could grow these rare orchids. So the house had to be renovated and tidied up, the old cottage, and that television had to go. And there were no millionaires, and the millionaires-to-be had all admitted that this television wasn't as valuable as they had thought. So I finally got the television. And it was very interesting. It was a black and white television. When I opened it up, there were no integrated circuits at all. It had about 35, 40 transistors, the entire thing transistorized. No integrated circuits. So it occupies quite a sort of unique moment in television design, because it very quickly went from tubes to transistors, and very quickly on from there to having ICs which integrated most of the receiver chain, the intermediate frequency chain, and so on. But this one, it was all transistors, and it had a large number of these double intermediate frequency transformers here. And I thought this would be a really nice project to try and make a complete working QRP transceiver only from the parts inside that television, not adding even one extra part. I thought that would be a fun challenge. And I was hoping I would be able to make it work and bring it here and enter it in the homebrew competition. But, I always start on the VFOs in any project, and the VFO is the hardest part of the project. And there was nowhere near enough time. So maybe next year I'll have it done and I can bring it. So this was the only part which I made, was this Franklin VFO. And you can see this double intermediate frequency transformer here. I put the inductor on one of the original inductors from the intermediate frequency strip. I just reused it. And the other components I built inside one of the other inductor cavities. And so trying to get some shielding and some thermal insulation. So it was a lot of fun, and hopefully, as I say, I could finish the project eventually. As soon as you've got a VFO, you're going to want a frequency counter so you know what frequency it's on. And I came across this website, Papa Alpha 2 Oscar Hotel, Ono, in around 2004. He's still got the same website. It's one of my favorite websites. I think I put the reference to the website in your book. And something about his website and the way he describes his projects and the way he builds them, I find very inspiring. I always found it very inspiring. And he had this very simple frequency counter that he'd built from logic chips, 7.4 series logic chips, 3 logic chips. He's got 8 LEDs on there, and the LEDs indicate the frequency from the band edge, 200 kilohertz, 100 kilohertz, 50 kilohertz. So depending on what LEDs are lit, you can add them up and work out what the frequency is. So in his example there, the 100, the 25, and the 3 LED is lit. So it means he's 128 kilohertz from the lower band edge. And I thought that was amazing. What a nice idea. But I looked at his project, and I decided to make my own version, which was even simpler and used only 2 logic ICs. And I had a lot of fun with this project, and I made all these different variations. So there was the first one I made had a output LEDs at 64 kilohertz, 32 kilohertz, 16 kilohertz, 8 kilohertz, 4, 2, 1, and 0.5. And so you could add those up. For people who didn't want to add up inconvenient numbers like that, there was a binary coded decimal version with 4 LEDs per digit. So you lost the 0.5 kilohertz resolution, but it was easier to add up and to read it. And it was even possible with the addition of 1 extra IC to make one with an IF offset for an intermediate frequency superhet. So it's really a lot of fun. All these transistors and all these diodes here in the middle, sorry, not transistors, these diodes here in the middle are me cheating by saying that it's only got 2 logic ICs because they actually implement an exclusive OR gate. And I had a lot of fun over the years working with logic gates made from diodes and resistors. And it's also an ideal thing for Junkbox. If you don't have logic ICs, but you need some kind of logic function, you can often get these just by using resistors and diodes. These are the 2 examples that I built. One of them was on a piece of copper-clad ground plane PCB, and the other one was ultra miniature. You can see it there next to a paperclip. Basically the same function, but just a much smaller size and only about 1 or 2 milliamps of current consumption, the one on the right-hand side. These are some examples of some of the diode, resistor, and transistor logic which you can do if you need logic functions, but you don't want to include a 7.4 series IC. Just with some diodes and a resistor, you can make an OR gate or an AND gate. And I do that all the time in projects, particularly if you only need 1 logic gate and you don't want to have a whole IC. They typically have 4 in or 6 or something, the 7.4 series. And then you can add the transistor to add a NOT function or make it a NAND gate or a NOR gate. So, and these are very effective and simple. Now, this is a really nice project, number 2 in my lineup, which is a 80-meter transceiver that appeared in Sprat, the quarterly journal of the GQRP Club magazine, many years ago. I know the schematic is too small to read, but as I said, it's all in the book there. And he used this CA3046 NPN transistor array. It contains 5 matched transistors in one 14-pin DIL chip. They don't need to be matched in this application, so you could easily replace those with discrete transistors. And it's a very, very nice project. It worked so well for me. I was really had a lot of fun with this. And it's basically just got a diode mixer here, a crystal oscillator, and then an audio chain, sorry, the diode, I don't know why I'm looking at that, and here. The diode mixer is up here on the left, and an audio chain here that amplifies to the speakers. I added a Astable multivibrator as the side tone generator, and I added an IRF 510 here to boost the power up to about 2 watts power output. And then I had a relay for transmit-receive switching. I had a separate polyvaricon capacitor for the receive and the transmit frequencies pulling the crystal so you could get some offset. And so I added my own additions to the original project. And it was very effective. And I took this in around 2005 on a business trip to Greenwich, Connecticut, where I was working for a US firm at that time in their London office. And I had a my ATU, which I showed you earlier, the Junkbox ATU. I had that with me as well. And this board, which is my implementation of the Unichip. And you can see that I use the actual chip here. I said, you could use transistors if you want. And it was also the first time that I had used a micro switch as the key. You can see this here with a micro switch. I was using that as my Morse key. And that was so fun to use and actually effective to use as a straight key. And that later got implemented in the QCX, the first QCX transceiver in 2017. So it was a lot of fun. And you see there, I've pointed out all of that VN66, I think, is wrong. It should be an RF510. So I took this with me on the business trip, and I was staying in the guest house of the company. And in the evening, in the daytime, I went to the company's storeroom, and I asked if there was 8 D-cell batteries. And they looked at me a bit strangely. Why does this visitor from England want 8 D-cell Duracell batteries? But they gave me the batteries. And I got also a Cat6 network cable, about 3 meters long. And I unwound all the wire. I stripped it all off. I unwound all the wire. I twisted the wire end to end. So I made my antenna. And I had a PC power cable, which I plugged into the wall and stripped off the wire and got connection to the earth connection. So that was my ground, just mains power ground. I took a small water bottle from the fridge in the guest house room and tied the wire around and just threw it as hard as I could outside the window over the nearest tree branch. And that was my antenna. And I got the 8 Duracell batteries and I wrapped them up in a page of the New York Times, which I didn't read even one word of, but they kept leaving outside my door every morning. And with that, I had my 80-meter station. And so I spent every evening up there, having QSOs all around the US, out to a distance of about 1,500 miles, and with my 2 watts. And it was a lot of fun. And I had stolen various of these pieces of equipment, like the batteries and the Cat6 cable. But I kind of balanced that off because my expenses claim was almost zero because I was so busy on this QRP activation every evening that I didn't even eat pizza or order any food in or anything like that. So I think I balanced out the cost of those items. So lots of fun there. And one of the people that I QSO'd was the well-known QRPer John AE5X, who turned out to be only about 5 miles away. And he worked at Westchester Airport, which was opposite to our office, as a radar engineer there. So we agreed to meet the following morning for coffee at the golf club, which was next to my employer's office. And this is a picture of us in the golf club car park with John holding the Unichip transceiver. And we had a nice chat, nice coffee. It was very nice to meet a QRPer randomly like that, who was so close that we could have coffee the following day. It was quite a long queue, so we were tapping out, I have brown hair, I have a blue shirt, I'm going to have this. And so we would recognize each other when we reached the golf club. So that was really nice. Now I come to my number 1 favorite Junkbox project. This one was a 1-tube 5-watt transmitter that I first saw on the website by Jan SM5GNN. And it was also in the RSGB Radcom's Tech Topics column by Pat G3VA, who used to write that column. I think he wrote it every month for over 50 years. So it was quite an amazing achievement. So it used the ECL82 triode pentode tube, which in the US would be a 6BM8. And if you want to have a go at this project, you will find no difficulty whatsoever finding this for $1 or $2 at the Hamvention tomorrow. It's a very common tube that was used in the audio output amplifier stage of radio receivers. And a little bit of a word about safety. Otherwise, this being America, you're all going to sue me for talking about this. If you die, please don't blame me. These tube transmitters do have quite high voltage. And if you are a person who has pacemakers and things, you probably want to pay extra attention. So here are some tips which I use to stay alive so far. You need to use a mains isolating transformer to make it safer. And this, if you don't have a mains isolating transformer with the right output voltages on the secondaries that you need, you can actually put two normal transformers back to back. So in the States, if you had 110 volt AC and perhaps you wanted, say, 300 volt DC at the end to run your transmitter, you would be able to use a transformer, say, 110 volt down to 12 volt, and then you feed that into a 6 volt transformer backwards, and it would put it back up to 220, and then rectify it, and there you've got your 350 volt or 300 volt DC. Transformers don't really like to be used in that way, backwards, and they're not really designed to be used backwards. But as long as you use a transformer that's a little bit higher power rating than you think you're going to need, it won't be too unhappy when you do it. So that's one way of doing it. But if you're going to Hamvention tomorrow, you may well be able to find a suitable transformer. I see them every year. I leave them there every year because, of course, I'm traveling on an airplane and transformer iron is a little bit heavy. That won't apply to many of you. Of course, you have to switch everything off before putting your fingers inside and poking them around. Otherwise, you're liable to be jumping back a few meters. And don't forget also that you've got capacitors in there to smooth out your DC supply, and these have to discharge. And you want to put a big, large value resistor in so that the power supply discharges when you switch it off, and you don't end up with high voltage stored on those capacitors. And one of the tricks which I always do, I always put a neon light in the project. So that light stays on after you've turned the power off until the voltage is decreased down below about 90 volts. And by that time, if you touch it, you're going to jump. It's not much fun, but it's probably not going to kill you. So I always put that in a project. I even do the same thing when I'm building a low voltage transistor project. I put an LED on the board. I really find it useful to have a visual indication or a warning of when a project is powered and you should be more careful of it, or when it's switched off. Anyway, that's all about safety. This is one schematic I had of the project. Again, you won't be able to see anything, but it's in the book. It shows the triode section there as a oscillator, and the pentode section is the power amplifier producing something like 3 or 4 or 5 watts output, depending on the band in use. I used to get about 5 watts on 80 meters. It dropped off a bit on the higher bands. And a unique thing I did here, you've got this minus 100 volts that you need. It's called grid block keying. So when you apply the minus 100 volts on the grid, it cuts off the power amplifier tube. And I got that 100 volts bias by a trick of DC isolating this second bridge rectifier with some unpolarized capacitors, and then rectifying it and using that as a second power source and connecting its positive output to the ground. So I got effectively a negative supply. And that trick I used a number of times, and it always seemed to work quite well. Now, this is a picture of the unit on the also built on single-sided PCB. I used in those days, the SRPB PCB, which is basically just compressed paper. It's not particularly good. It's much better to use FR4, much more rigid. And it shows the ATU there and the key I was using at the time. So I had a lot of fun with this project, and later on I added more crystals for other bands, and I added some relays so you would switch different taps on the output coil. And I had it working on 80 meters originally, but then I also had some crystals and switches for 40, 30, and 20 meters. And this was my station for the first few years of my ham radio operations, and all homebrew. If you want more bands and frequencies, there was a trick this picture came from the 1924 edition of QST. And it shows a guy grinding his crystals to change the wavelength, as it says there. And when you grind the crystal, you remove mass from it, and it increases the frequency. Modern crystals are very, very tiny. As soon as you look at them, they're going to break into 100 pieces. You wouldn't try and grind them like you could on the old crystals. But what you can do on the modern crystals is you can add some ink to them, and it will reduce the frequency. And so you use one of these Sharpie pens with a marker pen, permanent ink pens, and you just draw on the crystal surface. So you've got to somehow get the lid of the crystal off so you can see the crystal. And you just put some of that ink on and then remeasure the frequency, and it drops the frequency a little bit. So I had, for example, originally a 3.560 crystal, the QRP cooling frequency on 80 meters. And I could hear on my receiver all these guys on the FIST frequency, which was 3.558. And I know I was on the wrong sideband. My radio was set up on the opposite sideband to what you're supposed to use for CW. But I could hear all these stations on 3.558, and I eventually figured out they were FIST club members, and it sounded like fun, and I wanted to join them. But I couldn't get down there with the crystal I had. And so I got another crystal and added some ink onto it, and it very easily brought it down to 3.558. And I did that with a number of different crystals, and eventually I had a 12-way switch on the front panel where I could select a crystal. And so there was a lot of fun with that. And this is, again, the same picture as before with my first ever QSO and the same station used for most of the QSOs that I had. This receiver here was all spread out on boards at the time and was made from a collection of various projects in the RADCOM, the RSGB publication, technical topics column. And I had a bunch of things in there. This was a phasing method receiver. So it was my early experiments in phasing receivers, which of course later made their way into the QCX transceiver, the first QRP Labs CW transceiver in 2017. So that was a lot of fun, and that's my top 10 projects finished. Now I want to make a little commercial break before we do some questions. I don't think Dave, where is Dave? He probably doesn't mind commercial breaks, small commercial breaks. So this is the QMX transceiver that many of you are aware of, and many of you probably have, which has three different versions of 80 to 20 meters, 20 to 10 meter, and a 60 to 15 meter. So we recently introduced a 60 to 15 meter version, which is, I'm told, an ideal band combination for SOTA, POTA, portable operations. And it's a huge amount of stuff that is packed into that tiny box. DSP, embedded STR, it's got the USB sound card built in, CAT control for transceivers with computer, SWR bridge, power meter, and it's the first birthday of it today because it was here 1 year ago, which I announced the QMX launch. Since then, we've sold about 4,500 of these QMX kits, which is also why I look so tired. It wasn't just a long trip to come here. But today I want to announce a new radio, which is called QMX Plus. And QMX Plus is a QMX, but in the old QCX Plus style enclosure. It's a more desktop-orientated enclosure with a front panel that would be suitable for sitting on a shelf on a bench. And it's basically the same radio as a QMX, but with a few additions and with a much larger format, which makes it easier to build, and there's plenty of space inside to make modifications. Until about half an hour ago, I'd never seen anyone make a modification on the QMX. Those of you who built it probably know that it's very compact inside. But actually, Adam just showed me some pictures of a guy who'd made a capacitive touch paddle amendment to the QMX. So it's the first time I've ever seen anyone modify it. It's quite a challenge to find some space inside there. But QMX Plus has an awful lot of space inside. It also has some improvements over QMX. It has coverage of all the bands from 160 meters to 6 meters. So you can see here it's got twice the number of low-pass filter slots, and there are 8 bandpass filter slots, which are actually implemented on 5 different toroids to get the bandpass filters. So 160 meters to 6 meter band coverage. It also has a built-in real-time clock. And so this is a CR2032 battery that fits on the back of the front panel. Battery is not included in the kit because we're not allowed to ship batteries by air. But this is a very common battery. You can find it anywhere. And Although I haven't measured it, the predicted current consumption of the real-time clock and the capacity of the battery, it should theoretically last for 20 years. So it will probably outlive some of us in this room, and it may well even outlive the duration of the radio. Now, it also has an internal GPS option, and you can see this is a very tiny board. It's about 18 millimeters by 16 millimeters, if I recall. That includes the same GPS module that I have in the QLG2 kit, but it's a smaller format version of the module. And this just plugs into a place on the board and exposes this SMA connector on the rear panel. And that comes including the same active patch antenna that comes with a QLG2 kit. The other detail about this, if people have tried with a GPS with a QCX transceiver or a QMX transceiver, you will know that it plugs into the paddle port, and you can't use it when the transceiver is in ordinary CW mode because it will key the transceiver. But in this case, the GPS is on its own dedicated serial port connected to the microcontroller, so you can leave the GPS connected all the time. It doesn't conflict with the paddle. This is a picture of the rear panel showing all the standard connections that the QMX has, but also this GPS antenna connection here. There's also an auxiliary connector here. The radio has 11 GPIO ports, which will be possible to use for future expansion and for your own projects and experiments. And 2 of these are brought out to this connector on the back, which can also be configured as a serial port. So there's a lot of expansion possibilities, which I'm trying to create here. It has this dev kit option, which is this PCB here, which fits on 11-meter plastic spacers above the main PCB, and has pads which correspond to all the locations on the board where you may want to connect GPIO pins or the I2C bus or the filters here, their switching signals. So all of those should be conveniently accessible. The kit price is $125 for the kit and $25 for the enclosure. So it's only about $18 more expensive than the QMX, but with quite a lot of additional functionality and the extra band coverage. The internal GPS is $21. The dev kit is $8, not $8.50, which is indicated there. And we will also sell it in an assembled version for an extra $60. So the kit is ready. We have some here, and I will have them here this evening at vendor evening. And the manual is also ready and will be published shortly after this talk when I enable the web page. So it's an upgrade to the QMX. It runs exactly the same firmware as QMX. And so every continuing development that occurs on the QMX, like the SSB implementation, which is the next big thing on the QMX, will also apply to QMX Plus. And it does have a microphone here on the right-hand side here with a little hole in the panel. It's quite nice. The backlight from the screen shines through the hole as well. So it's got the built-in microphone there, but you can also plug the microphone here on the front panel in the paddle socket as well, like you can on the QMX. So that's my announcement and the end of my shameless Commerce Division commercial break. Sorry about that, Dave. So that's the end of my presentation. Thank you very much for listening. And if there are any questions on the Junkbox projects, please go ahead. Thank you.
Hi, Hans. Easy question. What was the year of your first QSO that was in that one slide?
The year of what, sorry?
The year of your first QSO.
2002. It was March 2002. I was actually licensed in 1994, soon after leaving university. But then I started my first job and was busy and everything, and I kind of was away from amateur radio for about 8 years. 2002 was the first QSO, all homebrew station.
W5LNA, Kevin, St. Paul, Minnesota. Any thoughts on building a waterfall display?
Yes. It is something that several people have mentioned. It's, you know, it would start to look like one of Ellicraft's K-line where they have all their pan adapter and all of this stuff. We have to call it the Q-line or something. Yeah, it's something I've thought about. I haven't yet had time to move in that direction, but it may be something in the future. There's a lot of projects I would love to do in the future, and even, you know, make modules. You can see in the inside here, down at this corner, there's a 2x5 pin header right by the RF output. And when you build the kit, you have to put a jumper across 2 of those pins. The idea I had was that if you didn't put that jumper across, you could, and if I later designed an auto ATU module, then that could fit inside the radio as well. You know, there's so many things to do. I'd love to design a pan adapter, waterfall display, but
Hey, Hans.
it takes a lot of time to design anything. As I said, 9 out of 10 projects never work. You never hear about those. So
Steve, W5RX, Las Cruces, New Mexico. I've built a lot of the kits. You talked about having GPIO pins and things available, but your software is closed, which we understand,
yeah.
and I support. So have you thought about a way to allow us to be able to do I2C expansion or something else off of there?
Absolutely. It's a very good question, and perhaps one I should have addressed in the speech about it. Many of you may be familiar with the U4B, the balloon tracker project, that runs its own version of BASIC, which I wrote. So I have a lot of plans for QMX, and the CPU utilization of the processor is about 40%. The utilization of the flash memory is even less than 40%. So there's an awful lot of expansion possibility in the code in QMX, and I have a lot of plans of what I want to do with it. And one of the things I want to do is include this U4B BASIC, which would give you full control over every aspect of the radio. You'll be able to change the way the user interface works, change the way the GPIO pins are used, what they're used for, because very much I would like this to be used for people who, you know, want to. Sorry, how do I get back to the slides? For people, I pressed the wrong button there, but people who want to build lots of different things could be built into here, but you need, as you said, a way to control them. So the SSB is my next big thing that I want to include in QMX. A lot of people are waiting for. And there's a whole suite of various more minor bug fixes and annoyances which also need to be fixed. But the U4B BASIC will be the way to do that. So it'll be a very, very easy thing, an easy way to do it, that everyone will be able to do it, not just programmers.
Okay, there's one down here, but I'll ask another question, Hans, right now while we're walking down here. This is from our Zoom chat. Craig W9CTW asks, is it going to be available soon? This is for the QMX on your website.
The QMX Plus, I think, yeah. It will be available on the website probably in the next few minutes. I have written the web page. I just have to, when I sit down, enable it on my phone. So I will make an announcement on the web page and on the forum, and theoretically that it should be possible to order it on the website within the next few minutes when I've had a break and a coffee. And we will have some at Hamvention, and we'll have some here tonight for those of you here if you want to build it. There's another question.
Yeah, Hans, great talk. I just wanted to mention on your one tube transmitter that many tubes were purpose-built. And that 6BM8 EL82, I think, was purpose-built for record players. And so that they wanted to have a single tube if you had a cheap record player. The ceramic phono cartridge could drive the triode, and then the other stage would run the speakers. And if you were really rich, you had a stereo with 2 of them. So that tube, by the way, I think is used in the HW101 Heathkit. So.
Thanks. Very interesting information, Greg. The expert on tubes, so he'll look forward to your talk later.
I was left about 8,000 square feet, piled 4 feet deep of stuff by my dad, who I have probably the world's largest collection of tuning units for BC 375 radio transmitters in existence. But the point of this is I have 82 tubes that were made for a tank intercom. It's a 6L6 with a 2.5 volt filament. And those are available for cost of postage if anybody wants one.
The 6L6 is a very nice tube. I haven't made any projects with it myself, but if you Google around, you will find quite easily some transmitter projects with a 6L6. So very good potential Junkbox project. And Reg over here is offering them for postage if you need one. So great stuff. Any other questions? Great. Thank you very much.